Hello students, welcome back. Let's go to section 2, radical equations. Oh boy, this is gonna be a tough one. We're talking about these kind of problems. Equations involving radicals. Here we have a cubing root, and luckily we have only one radical. Here we have two square roots. Of course, dealing with two radicals is going to be harder than just one radical. The key technique is this. Isolate the radical and take the nth power of both sides so that we eliminate a radical. So if this had been given originally like this, then we have to change it like this. Isolate the radical, and then take the nth power to kill off this radical. So if you have a radical expression with other things, then it's important to isolate the radical. So if you take cubing root, if you take the cube right here, it's not going to work. You have to isolate it and then do it. I think this is worthwhile, so let me just keep it. Okay, here we go. How do we handle this? Remember to isolate the radical first. So we have the cubing root of 2x minus 4, the cubing root of it is equal to 2. And now it's okay to take the cube of both sides. Let's copy and paste this thing. And then let's take the parenthesis here, third power, and then let's take 2 to the third power. By design, cubing root and cube will cancel each other out, and we have 2x minus 4. The right hand side, 2 to the third power, what is it? 2 times 2 times 2, that's 8. Now it's easy. 2x is equals to, flip it over to the other side, we have 12. Looks like that's what we are getting. Is everything correct? Let's copy and paste this thing, and let's ask Mathematica if this is right. The computer algebra system agreed with me. X equals to 6 is the solution. And this is how you do it. Isolate the radical and take the power. And that's how you can remove the radical. Once that is gone, it's easy from here. But then again, problems are generally not that simple. This was simple because we had only one radical. If we have two radicals like this, it's not going to be that simple. Let's see. One of more common mistakes is like this. Take the square of both sides directly here. So take the square of both sides. Okay, take the square, so we have 2x plus 3. And then take the square here, x plus 2, and that's equal to 4, and so on and so forth. Tell me why this fails. You can stop the playback and follow through if you're unsure. Well, you can check it out. This is equivalent to this times that and try to FOIL it out. Are you going to get something this simple? Or do you get something far more complicated? I'll leave the details to the students. In short, this doesn't work. You cannot remove two or more radicals in a single step. 2 radicals, you're going to need 2 steps. If you have 3 radicals, you're going to need 3 steps. You can remove radical only one at a time. Isolate it and take the power. So we have 2 radicals, and isolate one, take the power, and then isolate the other, take the power. It works like that. So how do you do that? This is a long problem, so let's go to the answer key here. So isolate one radical. Let's flip this one to the other side, and then square both sides. Here we go. Flip this to the other side like that, and then square both sides. Does it make sense? Now, if I square both sides, the left-hand side square and square root will cancel each other out. I'm going to get 2x plus 3. What do you have in the right-hand side? Square, and then square. Is that it? Is that it? No. What you just did was this. A plus b squared is a squared, which you did here, plus b squared, which you did over here. But is this correct? This is not correct. We need this. That's a complete square formula. So you cannot remove 2 radicals in the same process. You need 2-step process. Take the square of both sides. You can remove this radical, okay, but the other radical will not go away. The hard part begins now. This one goes away, but this one, well, this is not going to be a simple problem. FOIL it out and you get, well, the right-hand side. Please check your computation. And then simplify the right-hand side like this, taking the like terms together. And then flip these to the other side by taking the like terms together. And finally, we are ready to take the second step. We isolated this square root to the right-hand side, so we can square both sides now. Am I moving too quickly? Stop the playback and follow through. Isolate one radical, flip this one to the other side and square both sides. That'll kill off one radical, but the other radical will stay. It'll stay as complete square like this. So you have to take the like terms together and isolate the second radical. That's what I did here. Take the like terms together, take more like terms together to simplify and isolate. Now square both sides. Okay, squaring both sides. Left-hand side is a complete square, and that's just polynomial, no radical, so it's much easier. Right-hand side, finally, the second radical will be gone. 4 squared is 16, and the square root squared is 6 plus 2, so we have this in the right-hand side. And breaking out the parentheses, you get 16x plus 32. So we have this left-hand side, x squared minus 6x plus 9, and the right-hand side is 16x plus 32. Flip everything to the left-hand side, we have the standard form of this quadratic equation. Luckily, it can be factored, and then we have solutions, x equals 23 or x equals to -1. Feel okay about this? All good? Cannot be good. This is a tough one. First manipulation is difficult, but still, the hard part is just beginning. all these. And then indeed we got that. Let's check the answer. I got my mathematical command here, and let me use computer algebra system to check what's the solution. And we have x equals to 23, all right. But x equals to -1 is not in there. What's happening here? This is not there. This is okay. This is not there. What's going on here? Well, always check your answer. All right? Whenever you have denominator, always check your answer. We see through that in the previous lesson. Whenever you have radical, even more importantly, always check your answer. As a matter of fact, no matter how simple the problem is, always check your answer, period. Okay, let's check your answer. Plug those into the original equation. Once you plug in x equal to -1 and run it through, you don't get the right answer. You get 0 is equal to 2. That's not right. If you plug in x equals to 23, you end up with 7 minus 5 equals to 2. That's okay. Please stop the playback and check through this computation. Tedious, but they're elementary nonetheless. So what does this checking process tell you? They tell you that x equals to -1 is not a correct solution. It's an extraneous solution. X equals to 23, that one's legitimate. The reason, this equation obtained by squaring both sides eventually leads to that, is related to the original equation, but not necessarily the same. They're related, but not the same. Not necessarily the same. So the solution here, actually vice versa, solution there will be a solution here, but not necessarily vice versa. Not all the solution here will be solution over there. So you have to check your answer. We have two candidates, x equals 23, x equals to -1. Go back and check them both, and we end up with only one of them correct. That's very, very typical for radical equations. As a matter of fact, here's a summary. It's important to isolate both sides. Isolate the radical and then square both sides. Isolate first and then square both sides. Next, the original equation and the derived equation are not the same. Derived equation, the name is not that important, but what I'm saying is the original equation, this one, versus the quadratic equation that we ended up with, the derived equation. They're not the same. Related, yes, but they're not the same. So always check your answer. Now, can you do the same thing for the other two problems? They're going to be long, but you can do it if you use the same process. If you do it right, you're going to get one solution like this. If you do it right, you're going to get this time two solutions. So in this case, check your answer, then one of them will turn out to be extraneous, so you can throw that away. But this time, both of them will be valid solutions. How do you work it out? Well, I'm going to leave that part to students. I'll say section 2 is done, and a fair warning. This section 2, radical equations, is really, really tough, as you have just witnessed. So there is relatively small amount of chance you're going to see this kind of thing in the exam. I'll say 50-50 or less. The probability exists. Yes, there is chance, but study these kind of problems after getting comfortable with far more important topics first, the standard topics first, and then if you want to cover everything like blanket and you want to earn an A in this course, now is good time to go to problems like this, radical equations. You see, missing some problems that everybody is getting right is going to be devastating, but if you miss a problem and everybody else also missed a problem, that's not going to be too bad.